Right, so learning outcome 9 is about the challenges associated with space exploration. Right, so we looked the other day briefly, we'll come back to it in a wee bit more. We've got the problem of travelling large distances. Right, the distances involved in space are huge. So what we need is that basically our current methods, which are mostly based on rockets, won't work because we can't carry enough fuel with us. Right, in space itself it's empty, so you can't kind of gather fuel as you go along. So what we tend to do is to use what are called low propulsion methods. Right? So low propulsion methods are used which provide a very small unbalanced force over long periods of time. And examples of that are ion drive, where you can use either chemical ionization or radioactive ionization, and then you use the repulsion between similar ions, so between positive ions, to actually make things move. And the other one I mentioned the other day, solar sails, not cells, which use the pressure of light. Okay, another way of travelling large distances, using the catapult or gravity assist method. A spacecraft flies close to another planet or moon, and is accelerated by its gravitational field. So our next challenge is the idea that manoeuvring a spacecraft, which is going to be big and heavy, but if you're trying to manoeuvre it in low friction situations, it's going to require great precision. And special training. I think I'm going to have to go into another one. Yeah, maintaining sufficient energy systems and other essential systems as well. Most of our methods for this are based on solar cells. Right, so converting the sun's light into electricity. Okay, so learning outcome 10, the risks associated with space exploration. So during takeoff, there's a large amount of fuel on board. So with increased risk of explosion. And then we discussed the ideas of re-entry. So we talked about the idea if you're coming at too steep an angle, you're going too fast, too much heat energy generated, you burn up. But there's also a risk of skimming off the atmosphere. If the angle's too shallow. So one of the risks we talked about is the idea that you're exposed to large amounts of radiation or high levels of radiation. Which our atmosphere would normally protect us from. And the last one we talked about was the extreme environment in space, i.e. very low pressure and temperature. Right, last one for now then, learning outcome 11. Right, so how do Newton's laws apply in terms of space travel? Well, if we just take the Newton's laws in order, first of all, so Newton's first law is important. During the part of the journey in space, where there's no air resistance, and weaker gravitational forces. The spacecraft will continue at the same speed in the same direction. And I'll put in brackets there, roughly, because we're not saying there's no gravitational forces. Just much weaker than we're used to. Newton's second law applies during takeoff and landing where the thrust of the rocket and weight combine to provide the unbalanced force. Newton's third law is the basis of how rockets work. The rocket pushes what are called the exhaust gases out the back, and by Newton's third law, the gases push the rocket forward. With the same force. In the opposite direction. And notice there's no other object involved. It doesn't have to bounce off the air or bounce off the launch pad. It's just a rocket and exhaust gases.